Okay, let's talk a little about each of mentioned equipment. Let's start from repeaters. In telecommunications, a repeater is an electronic device that receives a signal and retransmits it at a higher level or higher power or into the other side of an obstruction, so the signal can cover longer distances. Here you can see two computers which are located far from each other. The distance between them approximately 2.5 kilometers. A regular Ethernet RJ45 jack twisted pair cable can deliver the data up to 150 meters. It's theoretical, but in real life there is no signal or too weak signal after 100 meters. So how can we deliver the data or information from computer A to computer B? We can use repeaters if we are going to build our network through twisted pair or coax cable. We need to set up to install repeaters each 100 meters distance to reach the computers. The term repeater originated with telegraphy in the 19th century and referred to an electromechanical device used to regenerate telegraph signals. Repeaters are used to boost signals in coaxial and twisted pair cable and in optical fiber lines. An electrical signal in a cable gets weaker and the further it travels due to energy dissipated in conductor resistance and dielectric losses. Similarly, a light signal traveling through an optical fiber suffers attenuation due to scattering and absorption. In long cable runs, repeaters are used to periodically regenerate and strengthen the signal. A network hub is one such device. We will talk about the network hubs in the next slide. An optical communications repeater is a piece of equipment that receives an optical signal, converts that signal into an electrical one, regenerates it, and then retransmits it as an optical signal. In contrast, optical amplifiers, which amplify the light beam directly, are often used in transcontinental and submarine communication cables because the signal loss over such distances would be unacceptable without them. I mentioned here transcontinental cables. So, what do you think? How do Europe communicate with North America, for example? Of course, there are transcontinental cables, fiber optic cables, through which the communication happens between Europe and North America. Let's talk about the radio repeaters. Radio repeaters are used in radio communication services. A radio repeater consists of a radio receiver connected to a transmitter. The radio signal is received, amplified, and retransmitted, usually on a different frequency. But in our case, it doesn't matter because we are just talking about the schematic about the principal work of the repeater. So higher radio frequencies are limited to line-of-sight transmission. Their range is blocked by mountains and the curvature of the earth. So repeaters are located on hills and mountains to retransmit the signal beyond the obstruction. Radio repeaters are also used extensively in broadcasting, where they are known as broadcast relay stations. These extend the broadcast coverage area to remote communities outside the range of the main broadcast station. A digipeater is a blend meaning digital repeater, particularly used in amateur radio. Store and forward digipeaters generally receive a packet radio transmission and then retransmit it on a same frequency. It's similar to Ethernet repeaters because in this case the amateur radio broadcasts over the packets. When providing a point-to-point telecom link using radio beyond line of sight, one uses repeaters in a microwave radio relay. A reflector, often a mountain top, that relays such signals around the obstacle is called a passive repeater. In this case, we need only antennas looking to different directions and connection between that antennas. Advantages of the repeaters is that make it easy to expand a network over a large distance. Another advantage is the connection between various types of media is possible. For example, a repeater could have coaxial cable and fiber optic inputs, which are also outputs, and in this case we convert the optical signal to electrical signal and will reach to a remote site through coaxial cable. Disadvantages of the repeaters are traffic cannot be filtered to ease congestion. Because of broadcasting traffic, about which we will speak later, they will allow broadcasting traffic to go through the repeaters, and it will make a congestion in other side network, which could be not only one computer but a huge network, huge LAN network. A repeater, another disadvantage is that a repeater cannot work across multiple network architectures. It means that to implement a repeater, we need the detailed diagram of the network, and we cannot create collision domains there. Repeater will not divide the whole collision domain into small subdomains. Before the invention of electronic amplifiers, mechanically coupled carbon microphones were used as an amplifiers in telephone repeaters. After the turn of the century, it was found that negative resistance mercury lamps could amplify, and they were used. The invention of audition tube repeaters around 1916 made transcontinental telephony practical. In the 1930s, vacuum tube repeaters using hybrid coils became commonplace, allowing the use of thinner wires. In the 1950s, negative impedance gain devices were more popular, and the transistorized version, called the E6 repeater, was the final major type used in Bell systems before the low cost of digital transmission made all voice band repeaters obsolete. Frequency frogging repeaters were commonplace in frequency division multiplexing systems from the middle to late 20th century. As you can see, as you can learn, we have discussed not only the Ethernet repeaters, but the repeaters overall.